I'm India from the Washington State University Chemistry Department. I'm going to be going over the colligative properties post-lab calculations. So the first one is talking about the average boiling point of your solution. So that's going to be your salt and your water solution. An average boiling point, you're just going to take your points from your graph. Your graph looks just about like that. And you're going to have a flat spot right in here. You're going to take 4 temperature points and you're going to take an average. So T1, T2, T3, and T4. And you're going to divide it by the number of samples, which in this case is 4. And that's going to give you your average boiling point of your solution. So in this case I use T1, T2, T3, T4 to stand for just any generic temperature point. You're going to take your actual numerical values, add them together, divide by 4. The next question is asking what the average boiling point of your water is. So you had distilled water. So this was your salt. And then you're going to do the exact same calculation, average boiling point of your water. So again, your T1, T2, T3, T4, all divided by 1, 2, 3, 4. Average boiling point of your water. So question 3 is asking what your actual boiling point elevation was. So all that means is the difference between your boiling point of your water and your boiling point of your water and salt solution. So to do that, and we would call that delta T. So change in temperature between the boiling point of pure water and solution is just going to be your average boiling point of your salt solution minus your average boiling point of your pure water. So then that's just going to give you your change in the boiling point between these two for your actual experimental data that you collected doing this experiment. So question 4 is about Van Hoff factors. And these are really just asking how many ions are your salts going to form when they dissolve in your solution. So your 2 salts are calcium chloride and sodium sulfate. So we'll start with calcium chloride. Calcium chloride, when you put it in water, it's going to dissociate into a calcium ion and then 2 chlorine ions, which I know because there's a 2 here. So we're going to have, chloride ions. So we're going to have a chloride. So you have a calcium, 2 plus, and then 2 chloride ions. And then you're going to have, for this one, we have a sodium ion, we have another sodium ion, and then we have a sulfate ion. Like that. So your Van Hoff factor for both of these, you just count your ions. So for this one we have 1, 2, 3. For this one we have 1, 2, 3. So Van Hoff factor for both of these is just 3. Okay, so question 5 is a little more involved. So in step 3, we calculated the actual boiling point elevation, but in this one we're going to calculate the theoretical boiling point elevation, which is what, in a perfect scenario, in a perfect world where everything went right, what would the actual boiling point elevation of your solution be? So that equation is 0.512 degrees C over M times I. So this is your boiling point constant for water. This is molality, not to be confused with molarity. And this is your Van Hoff factor, which we did over here. So, first step, what is molality? So molality is moles of solute per kilograms of solvent. And the way that I remember solute versus solvent is sort of a silly moniker, which is that your solute is dilute. So your solute is the thing that you dissolve in water, usually water. And so when you take your solute and you dilute it with water, it then dissolves. So your solute is the thing you're dissolving in your solution and thereby diluting it. So I just like to come up with things that help me remember these because these are really easy to mix up and they're different, and it's important that you know and use them correctly. So we're going to take this, and step one, I'm just going to find the moles of my solute, which in this case, I'm going to pick calcium chloride. So I'm going to come up with just an example problem. So let's say that I have, I'll have 26.7 grams of calcium chloride, and I need to figure out how many moles I have. So I'm going to say, using my molar mass, which in this case I just looked up using periodic table, so it's going to be 110.98 grams per mole. So then we have this cancels, and we're going to get 0.241 moles of calcium chloride. So then for the next step, I'm just going to find my kilograms of solvent. So your solvent in this case is water. That's pretty common. So we're going to take, I'll say I have 46.9 mils. These numbers are made up. You're going to have different numbers. Use the ones that you get from your lab, from your actual experiment. So let's say I had 46.9 milliliters of water, and I'm trying to find kilograms. So my first step, going to convert to grams. So we'll say for every mil of water, I'm going to have 0.998 grams. So those cancel, then I'm going to convert to kilograms. So there's 1,000 grams per kilogram. These cancel, and I'm going to get 0.04468 kilograms of water. So now, final step is just to plug back into this equation. So for C, we're going to have, and in your lab, it doesn't explicitly break it up into A, B, C. I just do this because it helps me keep track of everything. I label everything, and at the very end, I plug it into my original equation, just so I keep everything straight. I know what I'm doing, I know what everything is, and I can just plug numbers in, and it's really quick and easy and straightforward. So our theoretical boiling point elevation for our salt solution is 0.512 degrees C over M, and remember this is a constant, so you're just given it, and then it's going to be times the molality, which we found is moles of solute per kilogram of solvent. So our moles of solute was 0.241 moles per 0.0468 kilograms, and then times our Van Hoff factor, which we found over here. No matter which salt you do, it's going to be 3, but specifically for calcium chloride is also 3. So times 3, and we get a boiling point elevation of 0.79 degrees Celsius. So the boiling point of pure water is going to be 100 degrees Celsius, and when you add this amount of calcium chloride to pure water, it's going to make the boiling point 100.79 degrees Celsius. So it elevated the boiling point by that much. And that was colligative properties. I hope that was helpful.